Hi guys, welcome back to our science class. It's me again, teacher Yuri. And in today's video, we are going to study a new lesson. It's chapter 8 on your textbook. It is called sound. Okay, so we are going to study this time all about sound. Okay, in this unit, you are going to you'll be able to describe the propagation of sound. You can describe the loudness and pitch of sound. You can measure the loudness of a sound using a sound level meter, recognizes the harmful effects of loud sounds, and you are also going to discuss ways to reduce noise pollution. So that is our objective for this unit. So let's start with our first lesson, which is how does sound travel? Okay, so basically, how are we able to hear sound from a distance? How can we hear sound when we're underwater? And how are we able to hear sound even from the sound that is outside our room? So we are going to learn that in this lesson, in our first lesson, which is about how does sound travel? Okay, so sound is a form of energy and it is produced by things that vibrate. So basically, sound is produced when things are vibrating. So for example, when we hit a drum, the drum skin vibrates and it produces the sound. Okay, so that is the source of our sound. Now, how can we be able to hear the sound when we are at a distance? Okay, so how does a flute produce sound? So basically, you use a flute through blowing air in a hole. So basically, if this is a flute, you're going to blow air in a hole. It is actually called the lip plate. So when a stream of air directed across a hole in the instrument, it creates a vibration of air at the hole. So basically, the sound of the flute is created through the vibration of air that we blow on the hole, and then the musician actually uses the holes, okay, in the flute to shorten the vibrating air column so that it can create a low-pitched sound or high-pitched sound. So vibrations from the source of the sound travels through a medium by making the surrounding particles move back and forth, creating waves. So for example, if mint hits a drum, on the other end, the drum skin vibrates. There is a vibration, and this causes the air particles around it to vibrate. So the vibrating air particles bump into other air particles, which vibrate and bump into the other air particles. This process continues, allowing vibrations to travel through the air. So basically, the vibrations are traveling through air particles. So Ning hears the sound when the vibration reaches her ears. So as the sound travels, the energy is actually gradually losing. That is why you can hear a softer sound when you are farther from the source of the sound than when you are near. So when you are near the sound, it is louder, and you are going to hear a softer sound or a more quiet sound when you go farther from the source of the sound. That is because the energy in the vibration is actually gradually lost along the way as they travel through air particles. So now we know that sound can travel through air using by the vibration of sound traveling through the air particles. So can sound travel through solids? Now we have a very simple experiment for us to understand if sound can travel through a solid. So you only need an earplug, a table, and basically a friend. for you to be able to perform this activity. So steps are, the first one, cover one ear with an earplug. So you cover your one ear with your earplug, or you can also use your hands or your fingers to cover your other ear. Press the other ear against the surface of the table. So you cover one ear and then you press your other ear on the table, on the surface of the table. Now get a friend to gently scratch the surface of the table. You can either scratch, you can either knock on the table, just produce a sound, and then observe what is going to happen. Now compare the scratching sound you hear with that when your ear is not pressed against the table. So basically you cover one ear with an earplug and then you put your other ear against the table. Okay, so your friend will scratch or will knock on the table, and then after that, after you heard the sound, you remove your ear from the table and have your friend scratch the table one more time for you to be able to compare which sound is louder. Is it louder when your ear is pressed against the table or when it's off the table? So I believe that when you do that, when your friend is scratching the table, when your ear is pressed against it, it actually is louder than it is when your ear is off the table. So there we can already see that sound can travel through solids. Another example of that, where we can prove that sound travels through solid, is when you close your room. You close your room, you stay inside, and try to listen carefully if you can still hear the sound outside. No? If it's a louder sound, for example, sound of cars or motorcycles passing by, you can still hear it. So basically, sound can travel through solid objects because it can get inside your room even through solid walls. You can still be able to hear the sound of cars, sound of dogs barking outside, or sound of motorcycles passing by. Now, since we already know that sound can travel through air and solid, now can sound travel through liquids? Okay, so we have another experiment. The materials would be 2 wooden spoons, a resealable bag, a water, and an earplug. So fill a resealable bag with water. You cover one ear with an earplug. Place the other ear against the bag of water. So you fill a bag with water, and then you are going to put it against the other ear and earplug on the other ear. And then on the other side of the bag of water, get a friend to tap 2 wooden spoons together. So you ask your friend to tap the wooden spoons or a wooden stick, a drumstick, on the other side where you have the bag of water. Now remove the bag of water from your ear and listen. Is the sound louder or softer than what you heard earlier? So you are going to compare with the bag of water in your ear and with the bag out of your ear, which is louder? Is it louder with the water in your ear or not? Okay, so remember when we said that as the sound vibrations are traveling through air and it travels through air particles, the energy is gradually lost as it goes farther. That's why you hear a softer sound when you're farther. So sound actually travels faster in water compared with air because water particles are packed in more densely. So the energy the sound waves carry is transported faster. Thus, it appears to sound louder. Okay, so the sound that travels through water appears to be louder because of that the particles in water, in liquid, is actually more dense than in the particles through air. So it travels faster, and the sound waves, the energy in the sound waves are carried much faster, and that it appears to be louder. Now, a sound can travel through air, water, and through solids. Now, sound cannot travel through a vacuum. Why? So sound waves are traveling through vibrations of particles in the medium, for example, air, water, solid, and stuff like that. So it's safe to say that sound cannot travel through a vacuum because there are no atoms or molecules to vibrate, so there is no medium for the sound to travel. That's why it cannot travel through a vacuum space, an empty space. Okay, so sound needs a medium for it to travel. That's why it can travel through the particles of solid, liquid, and as well as gas. And it cannot travel through an empty space where there are no molecules that the vibrations can travel through. So now we have understood that sound can travel through solids, liquids, and gases. Now sound travels the fastest through solids. It travels about 5 times as fast as in water than in air. So here we have the speed of sound. So in air it travels about 346 meters per second. Pure water, it can travel through about 1,498 meters per second, while at glass, it can travel through 4,540 meters per second. This is the speed of sound in different mediums. So it travels the fastest in a solid medium, and next would be in liquid or pure water, and also air is the slowest. So sound can bounce off surfaces. When we shout at a wall, the sound bounces off the wall and travels back to us as an echo. So for example, in spaces, in like big spaces, and we shout or we create a sound, sometimes we can hear the sound coming back to us. Okay, it bounces back to us. That is called an echo. So that is the bouncing off of the sound traveling back to the source, traveling back to us. It is called as an echo. So yes, sound can bounce off surfaces. Okay, and if the sound bounces back, it is now called an echo. Okay, so we have here something to think about. So which travels faster? Is it light or sound? Now I want you to look into that and maybe look into the information of which travels faster. Is it the speed of light or the speed of sound? Is it can sound travel faster than light? So this is the end of our lesson for today, guys. I hope that you understand something from our lesson. Let us go watch this following video for you to understand sound a lot better. And let's answer a few questions from your workbook to test your knowledge about our lesson for today. So I hope you have a great day, and I'll see you in our next lesson. Bye.
Hi kids! Today we will learn about sound. So let's get started. Sound is a vibration that can be heard by a human or animal ear. Sound is created when something vibrates, and faster the vibration, louder the sound. Like when the sticks hit the drum head. Drum head vibrates and produces sound waves. Even when we speak, our vocal cords vibrates, because of which sound is produced. So, every time we hear a sound, it's because of some vibrations that produce some sound waves, which reach our ears. So kids, cause of sound is a vibration, and it can travel through air, water, liquids, and even solids. Tootway has thousands of animated videos on math, English, and science to clear the core basics of these subjects. Let's see. Can sound travel through air? Take 2 spoons and bang them together. You hear the sound. It shows that sound travels through air. As there is only air between the source of sound and your ear. Now let's see, can sound travel through water? When you are underwater, or when someone's swimming under the water, he or she can hear all the sounds coming from the poolside. So it shows that sound can travel through water. Rather, sound travels faster in water than in air. Divers can listen to every sound that is coming from outside the water. This shows that sound waves can travel through water. Now let's see if sound can travel through solids. If someone knocks at the door from outside, the person inside the room can listen. And there is a solid object that is a door between the source of the sound and the ear. So it shows that sound can travel through the solids. If there is any loud noise outside the room, you can hear the sounds that are coming from outside the room. That shows sound can travel through solids. Now let's have a look at a simple activity. You can also perform the same. You just need a friend of yours for this activity and a table. Place your ears at one end of the table. That can be wooden or metallic. Now ask your friend to tap on the table with his hands on the other side of the table. You will find the sound much louder in the ear which is placed on the table. It shows that sound travels much faster in the solid medium than in air. Friends, till now, we learned that sound waves originates when something vibrates, like vibration of a string of a guitar when it's plucked, vibration of our vocal cords when we sing or speak, vibration of door when someone knocks it. Every sound wave originates when something vibrates. Now, let's see how this sound wave propagates or moves. Any vibration causes the molecules in the object vibrate, which in turn vibrates the molecules in their adjacent medium. Like when a door is knocked, molecules of the door vibrate, and they in turn vibrate molecules in the air. And this vibration passes on to the next and next molecules, and this way sound travels from the door to the listener. Tootway has thousands of animated videos on math, English, and science to clear the core basics of these subjects. Sound waves always need some medium to travel. Medium can be air, liquid, or solid. And denser the medium, faster the sound waves travel. In the vacuum, there is no matter. So sound waves cannot travel at all in the vacuum. Now, we will see why do sound waves travel faster in denser mediums. Gases or air is the least dense medium, and sound travels with least speed in air. Solids are the densest mediums, so the sound waves travel fastest in solids. Distance between particles in solids is very small, and so particles can pass the vibration to next particle very quickly, and so sound waves travels fastest in solids. Liquids are less densely packed, so sound travels second fastest in liquids, and air is the least dense medium. So sound waves travel with least speed in the air or any gas. So friends, today we learn about sound. We will learn more about sound in the next section. Now go ahead and take a quiz to learn more. Bye-bye.